Hello, my name is Adam, and I will be talking about Boom, privacy-aware monitoring of dementia patients with alerts. My introduction slash motivation behind this is dementia patients, which is a umbrella term for a group of diseases that affects memory and thinking. As of 2020, there was 55 million people with it, and by 2050, there's projected 139 million people, and that's because its highest contributing factor is age, and as the population ages, more people have dementia. One of the outcomes of having dementia is something called wandering. This is where the person is unaware of where they are or how they got there. Um, and this has actually happened with my neighbor, where he would leave his house, go out onto the main street, and walk around, and um, his daughter was taking care of him, would come home, not see him there, and worry about him, not knowing when he left. Um, the tools that are used for building the algorithm are Yellow V8, Deep Sort, and Deep Face. Yellow V8 is a state-of-the-art uh, object detection system. Uh, Deep Sort is for real-time tracking, so it will track the objects that Yellow V8 has detected. And then Deep Face is a framework um, with optional use of recognition models, VGG Face being the one that I use, which was developed by Oxford University. Um, data sets used. Um, Yellow V8 requires trained weights, which can come from custom data or borrowed from someone that has already trained. And initially, I wanted to train the system myself, and so I did it. But each of the epochs turned out to be 30 minutes. That was too slow, so I then found out about Google Colab, which uses their graphics cards, and that became about 3 minutes per epoch. And uh, for reasons that I'll explain in the next slide, this turned out to be a dead end. And I then ultimately used two pre-trained weights. The first one coming from the COCO dataset, which consists of over 80 objects. Uh, and the one that I was most focused on is object 0, which is person. And then we have AKA name tov, trained some weights for people's faces. So I have a trained weights for person and face. Um, and in the beginning of this, I wanted to use yellow V8 to detect the person and to identify the person. So I came up with this drawing of this person with varying distances and angles, and took for about 100 pictures. And I was going to use these 100 pictures to train within these videos of person walking straight and then squiggly lines to then validate it. And that was my idea. But then I thought 100 pictures isn't enough, so I used these videos to get each of the frames, uh, identify the face, and then uh, and labels. So I did that, and I got about 1,000 pictures per person. I used that within Google Colab to train 100 epochs, and that is when I determined that face detection is not the same as face recognition, because while it would, I guess, identify the people within the dementia patients, it would not detect, or it would not identify strangers. It would always classify them as one of the people within the training set, which isn't good. So yeah, it's the difference between face detection and face recognition. Um, I took around 20 videos for testing purposes, and I took um, about 4 videos for the evaluation. Each of us walking through this door. We come straight at it, and I will show you in a second. And so the only data collection that was actually required was about 20 pictures per uh, dementia patient, and that was gathered from these. Selected about 20 of them, and use those. Um, this is the video. This is the original video. Pretty simple. Just go in the door, walk through it, walk past it. Um, and now going on to the algorithm. There are a couple sections to this. Initialize phase. Then we have the face logic, person logic, and leaving detection. In this first one, we set the directory for the face database path, which is just a directory with I guess 60 faces in it, one for each of the person. I have 3 dementia patients. Exit region, area of interest on the frame that you want to be able to detect if a person leaves. We initialize tracker, initialize the faces. We set the video path, and we read through the frames of the video, looping through them. I was only able to do this on an MP4 file. My computer was not fast enough for real time, but ideally this is a real-time application. For the faces, the face determines the name, or the face links to the name, and the name is in the database. So those are the truths. We try to link a face to the name. But we identify the faces. We get this track. We set up the tracker. Again, this tracker is supposed to. The purpose of the tracker is to give it an ID. In this case, 2, and it will maintain that ID from the moment it is detected until the moment it is undetected, and that way we can identify the person detected in each frame. For each of the faces detected, we determine if we should skip the face detection or not, face recognition or not, and it uses VGG face to do that from the database images provided. And if that distance is lower than a threshold, we add it to the face database. This one's in the face database. And if not, and if it is in the database, we lower it. So if this came back as, let's say, dad, I would lower the confidence from 9 to 8, because this may not be the correct person. And then we move on to the person. I guess the realization that I had is that each person has one face within its bounds. And with that, we detect each of the people. We track each of the people, again, to maintain its ID. And if the face bounds is in the person bounds, if this face is within the person bounds, set the face ID. Setting the face ID. If you squint, you can see ID 2. And if it's not, blur it. This person is not within the database, so this person is blurred. Next, we go into the leaving. So you have, at this point, you have identified the face. You recognize it as Adam. Now you have the person as Adam, and so you set your bounds, your area of interest in your frame to be, let's say, this corner. And if the person goes out that corner, you want to send an email. So, and it detects it based off the centroid of the person, which would be about right there for this one. And so it says if the person has not been detected in frame, which in 10 frames this person will have been gone, and it does have a correlating face, check its exit region, and then if it is in the area of interest, then send the email that this person is leaving. How I evaluated this, I did it locally on my Windows 10 computer with a 10-year-old i5 CPU. The metrics assessed were distances and evaluation times, computation times. Distances were cosine, Euclidean, and Euclidean L2. This kind of shows a different a representation of cosine distance, just an angle in between each of the faces. Euclidean is more of like a nominal distance, and then L2 is the calculated by taking the sum of the squared vector values. So this is my graphs for distance, and we will see this top row is mom, middle row is Adam, dad is the bottom row, um, with cosine, Euclidean, and Euclidean L2 distances being expressed. For cosine and Euclidean L2, you'll see the distance corresponding to the correct person gradually going down and then spiking up when they are walking past the camera. So its confidence level increases, and then spikes as it leaves, because kind of getting the side of the face. Euclidean distance um, did not end up working too well, because it would always be beyond the threshold, even though I did identify the person correctly. It was beyond the threshold of confidence. And then, so that was for use cases of just the dementia patient. Then I did an evaluation of a person not in the database. Person one, me in the green, um, was identified pretty confidently below threshold until I went off the screen, while person two was above threshold, but and it was identified sporadically between dad, the blue, its mom, and then a little bit of green up here as myself. Um, since that person was not identified correctly and stayed above the threshold, they are blurred, maintaining their privacy. Evaluation times, evaluation results of the times. Again, the skip kind of is a direct orient, um, it's directly associated to how confident the recognition is of the person, because if their confidence is 9, you don't need to recognize the person again. We'll see the biggest jump in improvement from 0 skips to 1 skip, and then 5 skips for each of the executions being the quickest execution time. Kind of wanted to show this. So it's not exactly healthcare related, but it is just related work, and it's taking the picture off your passport and using it to recognize your face, versus the TSA agent, and I find that pretty neat. It's kind of a facetious slide, but costs were about $9.99 for Google Collab, $35 for a computer camera, which did not end up working out, and every weekend spent doing this, because I kept on hitting a bunch of roadblocks, and I'll be able to delete a lot of these, but I used up about 200 gigabytes worth of hard drive space, downloading all of Coco dataset, and having about one picture for each of the 20 videos of uh, the bounding boxes, the face, and the person. And Chrome will be happy because I can delete all 99 tabs of that. My conclusion, it was a great introduction into computer vision, never having done it. It works as intended. It identifies me, my mom, and my dad pretty appropriately, and it did not identify the person. There are some pitfalls to it, such as the bounding box of the face being within the person. Um, that could work wonky when I guess someone is behind them, overlapping two faces within a person. Um, and the other thing that I was thinking of is that there's both a person weight and a face weight, making two separate inferences. If those can be combined, there would be one inference and cut the execution time in half, more or less. And then my I like that from after doing this, I can appreciate the airport example better, and kind of realizing how quote unquote easy it was, because if I can do it, it can't be too difficult to do. But I am assuming they're using better stuff. And so I guess I just wanted to show you something else. I showed you the original one. I will show you this. Identifying me. In the beginning it was blurry because I was misidentified or unidentified, and then once it detected me, I was unblurred. And I will run through this one with the unidentified person remaining blurry, again maintaining their privacy. That's it. Thank you. Oh, actually, I do want to show